Redox reactions stand for oxidation and reduction reactions, and they include single displacement, synthesis, combustion, and some of our double displacement reactions. In a redox reaction, one element is oxidized, which means it gains a positive charge, and another element is reduced, which means it loses positive charge, or instead of losing positive charge, we can talk about it gaining negative charge. First thing we want to do for a redox reaction is identify the charges of each element in each part of the reaction on both sides of the reaction. So for a simple reaction like this, look at the elements on the left. Elements always have charges of 0. So hydrogen has a charge of 0. Oxygen has a charge of 0, and when elements are in compounds, we assign them charges that make the most sense and the ones that we would expect. So we would expect oxygen to have a -2 charge, we would expect hydrogen to have a +1 charge, and so they are assigned. Our next step is to figure out which element oxidizes, which element reduces. As we look at this, we see that hydrogen goes from a charge of 0 to +1, so hydrogen oxidizes. Oxygen goes from a charge of 0 to -2, so oxygen reduces. What we're going to do now is write the half reactions for oxidation and for reduction, and we're going to balance the atoms first, and then we balance the charges. So if we start out with hydrogen, we have H2 on the left, so we need 2 hydrogen ions on the right. Total charge on the left is 0, so we need 2 electrons on the right. Can only balance charge by adding electrons. For oxygen, we have 2 on the left in O2, so we need 2 O2 minus on the right. Now we have a total charge of -4 on the right, 0 on the left, so we had 4 electrons on the left. So now each half reaction is balanced. Total atoms are balanced, total charge is balanced. The charge on each half reaction doesn't necessarily have to equal 0, but the charge for each half reaction has to be balanced, reactants and products. Now we're going to take these two half reactions and we're going to add them together. In order to do that, though, we need to make sure that the number of electrons in each half reaction is the same as the other. So with our two half reactions here, 2 electrons in the first, so we multiply the whole reaction by 2. We have 4 electrons in the second one, so we're all set. So for the first half reaction, we get 2 hydrogens, gives us 4 hydrogen ions plus 4 electrons. That we can add to our second half reaction where we have 4 electrons on the left, and now our electrons will cancel, which is what we want to have happen. We'll combine the hydrogen ion and the oxygen ions on the right to form our water, and there is our balanced equation. Redox is a little bit of an overkill for this reaction, but it's a good starter. Same thing here. We're going to identify charge for each of the elements in the reaction first. Start with the easy ones. So oxygen's -2. In permanganate, total charge is -1. 4 times -2 is -8. That means manganese has to be a +7. Iodide is -1. Manganese +2 is +2, and iodine on the right is 0. So now we have all of our elements identified with their charges. We can figure out what oxidizes, what reduces. When we're balancing half reactions, we keep oxygen and the manganese together in our permanganate ion, and we're going to balance that oxygen with water. I want to keep my polyatomic ions together. I don't want to break them up into manganese and oxide because that's more challenging to balance. So I'm going to keep them together, and in most cases I'm going to use water to balance my oxygen in my polyatomic ions. So here we have permanganate on the left goes to manganese on the right, and 4 oxygens in permanganate gives me 4 waters. The 8 hydrogens in water get balanced by hydrogen ions on the left. So the hydrogens from water get balanced with hydrogen ions. Now if I take a look at this half reaction on the right, I have a total of +2. On the left I have my +8 from hydrogen ions and -1, so that's +7. I need to have my charges balanced, so I need to add 5 electrons on the left. Now my atoms are balanced, my charges are balanced for this half reaction. The other half reaction's a lot easier. It's 2 iodides, and I need 2 because of I2 on the right. Total charge on the left is -2. Now I have 2 electrons on the right, total charge is -2. I I want my electrons in each reaction to balance, so I'm going to multiply the top half reaction by 2, bottom half reaction by 5, and then I'm going to be able to add them together so my electrons will cancel. So I end up with 16 hydrogen ions, 2 permanganate ions, 10 iodide ions, 2 manganese ions, 5 iodines, and 8 waters. It's a balanced reaction. My total charge on the right is +4 from the 2 manganese plus 2s. My total charge on the left is 16 plus, 10 minus, and 2 plus. So a total again of +4 on the left. So charges are balanced, atoms are balanced. It's a balanced redox reaction. When I have redox reactions in acidic solutions, I'm going to do what I just did. I'm going to balance any oxygen with water and use hydrogen ions to balance the hydrogen from water. So if I start with this reaction, I have dichromate, -2 for oxygen. Figure out the charge on chromium. It turns out to be a +6. I have ethanol. Ethanol is a polar molecule. I can still assign charges as if they were ionic. +1 for hydrogen, -2 for oxygen. If I add everything up, it turns out that carbon can be assigned, should be assigned a -2 charge in this compound. Remember, it's not ionic. We're just assigning charges for redox purposes. Carbon dioxide has -2 for oxygen. Now carbon is assigned a +4. So chromium reduces, carbon oxidizes. So those are our 2 half reactions. We'll start with carbon. Balance the carbons first, so we get 2 carbon dioxides. Then I look at my oxygens. I balance oxygen with water. So I have 4 oxygens on the right. I need 3 waters on the left. Now I have 4 oxygens on each side. Count up all my hydrogens. I have 6 plus 6 or 12 hydrogens on the left, so I need 12 hydrogen ions on the right. Total charge on the left is 0, so I need 12 electrons on the right to make my total charge on the right 0. Dichromate, I have 2 chromiums, so I have 2 chromium plus 3s on the right. 7 oxygens, so I have 7 waters on the right. That leads me to add 14 hydrogens on the left. And now I need to balance the charge. And if I count up my charge, I have +6 on the right, 14 -2s plus 12, so I need to add 6 electrons on the left. I need to multiply the bottom half reaction by 2 so that I get 12 electrons in each half reaction. Then I'm going to add everything together. If I cancel out my 12 hydrogens on the right, that reduces my hydrogens on the left to 16. If I cancel out the 3 waters on the left, that reduces my waters on the right to 11. Then I'm left with 16 hydrogen ions, 2 dichromates, ethanol goes to 4 chromium ions, 11 waters, and 2 carbon dioxides. So now everything's balanced, charges are balanced, atoms are balanced. If I balance a redox reaction in a basic solution, I'm going to do it a little bit differently. For oxygens this time, I'm going to use hydroxide, but what I do is 2 times as many hydroxides as I have oxygens. And then I balance the hydrogen from hydroxide with water. So starting out again, I'm going to assign charges to each of my elements in the reaction first of all. So my elements are 0. Within my ions, I assign the charges so that they add up to the total charge of the entire ion. So my cyanide doesn't change. The only thing that oxidizes and reduces are the silver and the oxygen. But wait, where's oxygen on the right? Okay, apparently this is an incomplete redox reaction, so we have to complete it when we balance it. We're going to start out with oxygen. So I use 4 hydroxides on the right because I have 2 oxygens on the left. That means I need 2 waters to take care of all my hydrogens, and then I end up with 4 electrons. So my charges are balanced, my atoms are balanced, in the first half reaction. For the second half reaction, I'm going to balance the silver, and I'm going to have both the silver and the cyanide ion on the left because I need them both together on the right. So all I need to do really is add 2 in front of the cyanide, and I get that balanced. I have to multiply the whole half reaction by 4 so that I get the same number of electrons in each half reaction. Now if I add them together, now I get the 4 silvers plus 8 cyanide ions plus 2 waters plus oxygen gives me 4 silver cyanide ions and 4 hydroxide ions. And that is how we walk through and balance redox reactions using half reactions. Remember, balance the atoms first, then balance the charges, and then add everything together when electrons are equal in each half reaction. And that's the rest of Chapter 4.